Thanks for joining me in the latest in this vlog series as part of Alteryx and Tableau in sport. Now, in this vlog series, we're doing 4 vlogs in 4 days as part of finding a replacement player for an outgoing player. Now, yesterday we looked at using the predictive grouping tools and in particular looking at principal component analysis. Today, we're going to be doing k-means clustering. First, I want to touch upon the basics of what is cluster analysis. Essentially, cluster analysis is the dividing of data into purposeful groups. Clustering data can aid in understanding your data better by grouping objects based upon shared characteristics, such as people of the same age with the same hobbies. When we cluster or group our data in Alteryx using the k-centroids cluster analysis tool, we have a choice of algorithms to use: k-means, k-medians, and neural gas. The algorithm that you use often depends on your data and your end requirements. For instance, in practice, k-means is easily affected by outliers, whereas k-medians is robust to outliers and often results in more compact clusters. And in the case of neural gas, this is a generalization of the k-means algorithm, where vectors are assigned to multiple classes with a weighting, as opposed to the k-means algorithm, where every class has its mean vector. Now, don't worry too much about this, but if you want to know more about these different algorithms, then there are plenty of resources on the web dedicated to this. In our example today, we will be using k-means clustering. You will see some useful links around the subject of k-means clustering on screen now and in this blog below the video. So first of all, we're going to open up the workflow we created for principal component analysis in part 1 of this vlog series, as this is going to form the base of today's workflow. If you haven't watched part 1 of this series yet, then now would be a good time to do so. So we have our 2 data inputs created from Octoref24 files. We are filtering to just centre or defensive midfielders. We are aggregating our required performance metrics across the whole of the 2010-11 season. Those metrics are ball recoveries in the middle third, interceptions and key passes. We are filtering to only those players who have played around 15 matches or more, and then normalising our performance metrics to be per minute. Finally, we carry out our principal component analysis. So I'm just going to run this workflow just to show you the output that we get. There we have it, all the players from the 2010-11 season who passed through our filters, with the set of performance metrics per minute and their principal component 1 and 2 values. And when we plot this on a graph, this is what we get. Each player plotted based upon our performance metrics and represented by a number in this graph. So now let's cluster our players into groups. So rather than having a position on the graph, we will have a selection of clusters, with each cluster representing players with similar levels of performance in our chosen metrics. Now we go to our predictive grouping section and drag and drop our k-centroids cluster analysis tool onto our workflow. And we are going to use the exact same stream of data that we used for our principal component analysis in part 1. So I'm going to connect the output of the select tool to my cluster tool. I'm going to give the cluster solution a name. One thing to note is that you can't have a space in your solution name, so I'm just going to replace my space with an underscore. I'm then going to select our 4 performance metrics, and in this case I'm going to standardise the fields using z-scores. I'm then going to choose my clustering method, and as mentioned earlier, I'm going to use k-means clustering. And now I have a couple of further options. I'm going to leave the number of starting seeds at the default value of 10, but I'm going to create 5 clusters or groups of players based upon their performance levels in each of our metrics. We then also have a few more plot and graphic options, but for now I'm going to leave these as the default values. I'm then going to add a couple of browse tools to the outputs of my cluster tool and run the workflow. If I go to my report, that's the R output of the tool, you'll see a similar output to the principal component analysis, but this time, rather than each player being represented by a number, instead each player is assigned to a group, 1, 2, 3, 4, or 5. Now, our O output from the cluster tool provides us with our clustering data. This initially may not make a lot of sense, but this is where we introduce another tool to our workflow that will make sense of all this information, the Append Cluster tool. So if we drag this tool onto our workflow and connect it to our output of our cluster tool, as well as our original incoming stream, and then add a browse tool and run the workflow, you will now see our performance metrics for each player, and alongside that, the cluster that they belong to. I'm actually now going to remove these browse tools and add a find replace tool. I'm going to connect our stream from our principal component analysis as well as our stream from our cluster analysis. I'm then going to match the inputs based upon the player ID. And from the top stream of data that has our principal components 1 and 2, I'm going to add in the cluster data. If we now add a browse tool at the end, we can see we have our performance metrics for each player, and alongside that we now have both our principal component 1 and 2 plots and the cluster that each player belongs to. This dataset is going to be used in part 4 of this vlog series when we start to visually explore this data in Tableau. So that's it for this vlog, but join me again tomorrow where we will be using the Find Nearest Neighbours tool in Alteryx to find similar players to Stuart Holden based upon their Euclidean distance.